Now, water and volume leads us to a thing called density. Density is a measure of how compact a substance is. When a substance is very dense, it just means it's more compact. Kilogram per kilogram, it takes up less space. We measure density in kilograms per cubic meter. Now, if we happen to know that a 10 centimetre by 10 centimetre by 10 centimetre cube of water weighs 1 kilogram, then a cubic metre of water would weigh 1,000 kilograms, which, by the way, we call the metric ton. And that means that the density of water is 1,000 kilograms per cubic meter. When we're looking at densities, it's always an idea to be thinking, how is this density comparing to water? You see, we're always comparing things to water because water's our standard. Now, if you look at things, if it sinks in water, that means it's denser than water. So ceramics, plates, that sort of thing, they sink in water. Woods. On the whole, most wood floats in water. Polymers, some plastics float in water, some plastics sink in water. Rubbers, some float, some sink. Metals are very much denser than water, so they pretty well sink. So, that always leads me to the question I normally ask. If metal sinks in water, what about the Titanic? Why didn't that sink in water? Any ideas?
That the boat takes up, and the way it's designed just floats.
Okay, why does it, well, it floated to begin with at the beginning of the film, but why did it float? Surface area? If it was as small as a small spider, then surface area, yes. But it's quite a biggish beast, isn't it?
I don't like the surface area of a small thing is obviously small, but if the small thing's made out of the same material, that'd sink as well, wouldn't it?
Yeah, it's not surface area. What I'll do is I'll give you a hint. That's the Titanic. That's the water level on the outside. On the inside, there's nothing apart from an old car, you know, and engines and stuff like that, and a woman in a ball gown, right? Now, if you look at the Titanic, these bits, the hull, they are made of steel, which is very dense. But the vast majority of the Titanic is actually made of air, which is very not dense. So when you look at the average density of a ship, the average density is less than water, so ships float. Of course, all you then do is you get an iceberg come along and make a small hole in the side, and all the water comes flooding in. Woo, woo, woo. Now we have women in ball gowns running around singing in high-pitched voices, and it all goes badly wrong, because this ship can't sink. She's made of iron, sir, I assure you she can. See how that works there? If you can give me a smiley face if you can see that. Okay, now, when we're talking about density, we always talk about density in kilograms per cubic meter. There is another way of talking about density. We talk about relative density and specific gravity. Now, relative density is when we compare the density of the thing that we're looking at with the density of water. With a reference subject. Specific gravity is when we compare it to water. Truth be told, we always compare it with water. So, in reality, relative density and specific gravity are the same thing. Now, I know there's chemical engineers out there that will say, oh no, they're very different. Oh well, you know, they're not. In reality, we always compare to water. Now, relative density and specific gravity give us a number, and that number is how much denser or less dense than water is the object. Whenever we're doing our calculations, we always do our calculations in true density. We always do our calculations in kilogram per cubic meter. So if you're ever given a relative density or a specific gravity, always convert it into kilograms per cubic meter before you do anything. Strange. Yes, I've got a hand up. I'm not sure who that is. I think it's John. So you go ahead, mate.
Just on the last one in the equations there, what was the P standing for? Sorry, mate.
Oh, rightio, that's not a P. That is a rho. It's a Greek letter, and it's row as in row, row, row your boat gently down the stream. And it looks like that. It's a Greek letter rho. Looks kind of P-ish, I know, but it's not. All good?
So what's that stand for? Is that just saying the pressure or the weight of the object, or what's the rho stand for?
Rho is density. Rho is density in kilograms per meter cubed. Okay? So the density to the row of water. So row of water is 1,000.
Yeah, cheers for that. Sorry, mate.
Don't say sorry. That's what we're here for. Right. Actually, hang on. Do I need to explain any more about density? Yeah, may as well. So, if I was to tell you that the density of aluminium is 6,000 kilograms per cubic meter, then let's just do that. So, density of aluminium equals 6,000 kilograms per meter cubed. So we would say the specific gravity of aluminium is 6. And what that means is aluminium, 1 cubic meter of aluminium would weigh 6,000 kilograms. And the specific gravity is 6. What that means is it's 6 times denser than water. If I said to you the density of, I should draw that, of oil is 800 kilograms per cubic meter, that would mean that specific gravity of oil is 0.8. Now, if aluminium is 6 times as dense as water, it sinks in water. If oil is 0.8 times as dense as water, it floats on water. So that's how we go from specific gravity to density. Specific gravity tells you how does it compare with water. Density tells you how many kilograms would 1 cubic meter of it weigh.